Okay, welcome guys to Learn More Fast. This is going to be a video on basic torque and equilibrium. So I've uploaded some notes for you guys to go over. I hope they're very helpful. Um, and I'm also going to just make this quick video because some of these need to be explained. And if you're a visual person, then you're definitely going to need this. So basically, just going through the pages that you can see online. Torque and equilibrium for Chapter 8. Basically, torque is defined as any force that causes rotation about a pivot point. So you can just basically look here, and you can actually see that as long as there is something fixed, or at some point on this bar that is fixed, it'll hold it in place. And what will happen is any force that is applied in any direction that is not on the pivot point, it'll rotate either this way, basically counterclockwise or clockwise. And it doesn't matter where the force is as long as it's not on the pivot point. And that's basically what it says in the next couple. So as long as no force is directed at the pivot point, the torque occurs. So you definitely need to know these formulas for torque. That's extremely important. Basically, the perpendicular force times the distance is equal to the torque. And here, okay, so in some cases, you'll have, and let's look on this side. I'm going to draw example. Basically, if you have in maybe I'm not going to draw a bar, but basically what will happen is sometimes you'll have a bar and they'll ask you to show a pivot maybe coming out at a 45-degree angle to the horizontal, right? So, and more than likely you guys already know this, but you're not going to calculate the force in this direction. That's a two-dimensional force, which makes it very difficult to calculate. So to make it easier, we're going to make it a one-dimensional force by calculating the x component and the y component. And basically how to do this, we're going to use this formula. And the reason we're not actually calculating the x component is because torque does not occur in the x direction. If you think about a bar, sorry about the drawing, but if you think about a bar and you think about its pivot point, it's never going to be going in this direction, right? It's always going to be either going up, or it's going to be going, it'll be either going down or it'll be going up. It will never be going in your x direction. It is always going to go in your y direction. Anytime anything happens in the y direction, it is always sine. Cosine only occurs in the x direction, so make sure that it's always sine. And basically this is just sine. This right here means angle. It's supposed to be theta, but basically your angle will go here, and the angle that will be given is either going to be here, well, it'll be right here, and you're going to be calculating this portion of it. And to plug it in, you're basically going to look at, this is your force going in this direction, so let's say maybe that's 20 newtons. How about that? So that's 20 newtons, and this is maybe a 20-degree angle. Okay, this is just going to be fairly basic. And so what we'll do is we'll just plug in your sine of 20. Okay, that might take a little too long. Let me try something else. Oh, here you go. Sine, it'll be 20 degrees, and you'll multiply that by your force, which is your 20 newtons, and that will give you your answer for your y component. Remember not to stop there. You still have to plug that into your perpendicular force times your distance equals torque formula. So all you're solving for here is your perpendicular force. You then have to plug that into here, multiply it by the distance that you're given, and you'll definitely see the distance, and it'll usually be the distance that's right here, maybe 2 meters, and that will equal your final torque. So just keep that in mind. Signs for torque, basically you just need to know clockwise versus counterclockwise. Clockwise is always in this direction, counterclockwise is in that direction. You can read up more on that. I put the notes up online. If there's more than one torque involved, you can basically set up a chart like this. So I'll just figure this out a little bit. Basically, if more than one torque is involved, use this chart. Okay, so you basically get the point. You have your F column. You only put the forces in this column. If the force, as I said, is in this direction, in maybe like a 45-degree, or any angle that's not 90 degrees or on your 0-degree mark, which well, basically could happen. If so, then you're going to have to use the F equals sine angle, and then your force that was given here. So you're just basically going to do this for your F column to make sure that all of them must be in the y-axis. Then your D column is basically the distance, like maybe this will be 2 meters. That's how long the length of your arm will be. And this is called a lever arm. So anytime I mention lever arm, or if I say the arm, this is what I'm talking about. This will be 2 meters length. This is your lever arm. Then your torque column, which is basically when you have your forces, you have your distances, and you just multiply across, and you get your torque. So that's basically what this is the easiest way to calculate your torque and be able to keep track of all of them. So when we're actually, well, actually, let me just read this out to you. It'll make it a little easier to understand. So once we're at equilibrium, the sum of all the torques will equal 0. So you can take your torque column and write it in a sentence which equals 0. So basically what you're going to do is you're going to take all your torques that are right here and set it equal to 0. That's basically what that means. This will allow you to solve for whatever your unknown is, if it's either a force or a distance, and that's pretty self-explanatory. And you can try one. I put up an example. I'm not going to go through it now. If you'd like me to set up a video, you can send me a link, or maybe if I have a little bit extra time, I don't mind putting it up. And basically, I'm not going to show you the answer yet. So if you have a combo problem, which is basically a problem where you have the same problem, torques and non-torques, which have like a little bit of both in it, and basically just as remember, it's a torque only if the force does not go through the pivot. So basically with the combo problems, again, picking a pivot point, you definitely have to have a pivot point in every problem. So if one has not been assigned to you, if you're in actually any physics class, most times the pivot is assigned to you. If it isn't, then basically just follow this one rule. It is best to pick the pivot all the way to the left side of the picture. So that makes it a lot easier on yourself. Doing a torque chart is basically what I just showed you. Foxy chart, it's similar. I can make a video on that later. The rest, it's all basically about the same. I'll probably make a video describing this if anybody has any trouble. But overall, most of it is self-explanatory, and there's another example. So I hope this helps you. If you have any questions, feel free. We have a forum. You can post there. Happy studying. Bye.